Hello and welcome to AI for Developers. I'm Chaitanya Talking Bot. Today's lesson is titled Tokenization and Embeddings. AI breaking down words and finding their meaning. Imagine you want to teach a computer to understand a sentence like, "The quick brown fox jumps over the lazy dog." Sounds simple for us, right? But computers only understand numbers, not words. This is the fundamental challenge in AI. How do we bridge the gap between human language and computer logic? This lesson will show you the foundational steps. Before a computer can even begin to think about what a sentence means, it needs to break it down. Think of it like building with Legos. You don't get a finished model, you get individual bricks. Tokenization is exactly that. Taking a block of text and breaking it into smaller, manageable units called tokens. For a developer, this is the very first programmatic step to process text. A token is the smallest unit of text that our AI model will process. It can be a whole word, apple, a part of a word, ing, un, a punctuation mark, single quote comma single quote exclamation mark, single quote, or even special characters. The way text is broken down depends on the tokenizer tool being used. Example, hello, world, might become, hello, single quote comma single quote, world, single quote exclamation mark, single quote, or just, hello, single quote comma single quote, world, single quote exclamation mark, single quote, depending on the tokenizer's rules. As a developer, you'll use pre-built tokenizer libraries. You feed your text into a function like backquote tokenizer in code. I love AI, backquote. What you get back isn't words, but a list of numerical IDs. Each ID corresponds to a specific token in the tokenizer's huge vocabulary. For instance, I might be ID 1045, love ID 2293, and AI ID 2054. These numbers are just labels. They don't carry meaning yet, but the computer now has something it can work with. Now we have our numerical token IDs, but they're still just arbitrary labels. ID 1 for apple and ID 2 for banana. Don't tell the computer that both are fruits, or that they're similar. This is where embeddings come in. Embeddings are the AI's way of understanding the asterisk meaning and relationships between words and concepts. An embedding is a list of numbers, often hundreds or thousands long, that represents a word or phrase in a multi-dimensional space. Think of it like a very detailed taste profile for food. Sweetness, sourness, bitterness, etc. are coordinates on an extremely complex map. Words with similar meanings, like king and queen, or cat and dog, will have very similar taste profiles or be located very close to each other in this numerical space. This is how AI sees similarities and differences. After tokenization gives you numerical IDs, you then pass these into an embedding model. A function like backquote model.get_text_embedding. I love AI, backquote would return a single, long list of floating point numbers, e.g., backquote 0.123 minus 0.456, 0.789, 0.001, backquote. This single vector is the meaning of that sentence for the computer. Key use cases. Semantic search. Asterisk find documents or products that mean similar things, even if they don't use the exact same keywords. Recommendations. People who liked this article also liked these similar ones. Sentiment analysis. Asterisk understand if a text is positive, negative, or neutral. Generative AI. These meaningful vectors are what large language models, LLMs, manipulate and generate from to create new, coherent text. So, we start with raw text. We use tokenization to break it into computer-readable numerical IDs. Then, we use embeddings to transform those IDs into rich, meaningful numerical vectors that capture the essence and relationships of the words. This fundamental two-step process is the bedrock upon which almost all advanced AI language understanding and generation is built. You've just unlocked how AI begins to think about language. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.